Alright, students, welcome to the next video lesson. Today we'll be looking at section 8.4, writing rules for linear functions. Now this part is a page from your textbook. I tore it out of the book from one of your books. I bet you won't guess whose. Anyways, you need to copy this down. It says you can write a function using function notation, in which you use f of x instead of y. You read this as f of x, f of x. That is how you read this whole f with the parentheses and the x. You can write the domain value, or you can think of it, as the input and the resulting range as the output. A function rule is an equation that describes a function rule. So this is a whole thing is a function rule. The y is the output, the x is the input. Over here, once again, still a function rule. They just use function notation instead of the y. X is what we put in, f of x is what we get out. Over here, x is what we put in, y is what we get out. I actually very much like the functions, because I think of them like machines. You put something in, the input, and it spits something out. It's like if you had a machine where you put a piece of metal in and it puts a stamp on it, okay? So if I put copper in the metal machine, it puts a stamp on it. If I put nickel in there, it puts a stamp on it. If I put a piece of gold sheet metal, it puts a stamp on it. So it does the same thing every time, but you do get different results because you put different types of metal in there. So the input is going to change the output we get, but we'll see that as we go along. So for instance, let's use this as an example. Basically today we are going to be, instead of given a function rule and told to create a chart like we did back in some sections before, we are going to be given a chart and told to, well, create the rule. That's what we're going to do right now. I'll stop talking like that because some of you are thinking, I don't understand a word he's saying. Okay, moving on. So here we have two different things. So this is just an example. This is like an example before the actual example. This is just a basics to help us understand. So let's say I had a machine where every time I put 1 in, it spits out 8. What did I do to that 1? I actually, well, with just one example, I don't know. There's a lot of things I could have done to it. So one example is not enough to know. If I see the second one, I get a better idea, and the third one helps me confirm my idea. So here it is. I put 1, it spits out an 8. If I put a 2 in, it spits out a 9. If I put a 3 in, it spits out a 10. What am I doing to each of these numbers? I'm doing the same thing. And if you guessed that I am adding 7, you're right. I am adding 7. Now over here, what am I doing? I put a 1 and I get a negative 2. I don't know. Maybe I'm subtracting 3? Let's find out. 2, I get a negative 4. That doesn't work because 2 minus 3 is negative 1, not negative 4. What could I be doing? Come up with an idea and see if the last one helps confirm it. 3, negative 6. Well, what happens to a 1, 2, and 3 to get these? I'm doing the same thing to each of these numbers. I would be multiplying it by a negative 2. That would be what I'm doing. I'm timesing it by a negative 2. So maybe you want to write down timesing by a negative 2 or adding 7 there to help you see it better. So that's what we're doing right there. Pretty simple enough. Now these ones are simple to see because they're one step, and honestly they're easy. If you couldn't see these right away, or sorry, not right away, but after looking at them for a while, you should be able to guess what's going on. What happens when we start introducing decimals or fractions, or we start adding 2 and multi-step rules. How are you going to know what it is based off just a chart? Well, there's a format we can use that makes this a whole lot easier, and that's what we're going to use today. So the type of work that you'll be seeing in class is stuff like this. It'll say, write a rule for the linear functions in the tables below. All right, so here are our tables. Boom, we have these two. We're going to look at this one first, then we're going to this one, and then we have two more that we're going to take a look at. So let's begin. So here's how it works. We've created our tables, and what we want to do is we want to find how much is the numbers increasing or decreasing as we move along, okay? So for instance, as I move from here to here, and here to here, and here to here, what is the change in the numbers? Well, it seems to be increasing by, so a plus 1. It's increasing by 1. Over here we have boom, boom, boom. How much is the change here? Well, it seems to be increasing by 4. All right. Now we create our rule by basically using the slope-intercept form that we learned about in the last section. You're going to have to write your f of x instead of y, though. Put f of x is equal to, and remember, the slope-intercept form was this, mx plus b. So again, we're going to write f of x equals, but instead of m, we now know what the slope is. It's going to be your y value, remember this is still y value, consider it like that, divided by your x value. So what is 4 divided by 1? Well, that's 4x plus, now how do I find b? So just so we can get an idea, this came from this, 4 divided by 1. This came from here, and this came from there, okay? So that's how we got our numbers there. So now I need to figure out how to get my b. And b is going to be equal to 8. Now, how did I get that? Well, here's how it works. If I were to plug in 0 for my x, 4 times 0 is 0. So I don't know what my rule is, but all I know is that when I plug 0 in, I get 8. So I know that I'm timesing it by 4 right now, and I know that I'm timesing it by 4, and I have to be adding something. And so if I plug in 0, that's going to tell me exactly what I'm adding, because whatever's left in this column is your y-intercept. Now you might not fully understand why it works right now, but as we go along, and if you're trying to understand it, trust me, it will eventually click. For right now, it's just helpful to know this, that whatever's across from your 0, that is your y-intercept, okay? If x is 0, where are you on the graph? Think about it. Where does x equal 0 at on the graph? The only place it equals 0 at is the y-axis. Along the whole y-axis, x is equal to 0. So if this line touches the point 0, 8, that's right where your y-intercept is. And what's the y value there? It's 8. I'm hoping this is beginning to connect, but like I said, if it doesn't, you will get it eventually. So this 8 right here is where we get this 8 right here, okay? So I'm just trying to help us out a little bit. The next one over here, we won't make as many red marks and stuff because we don't need them. Okay, next, what is the change as we go in this direction? It seems to me that it's increasing by 3. While over here, it seems to be increasing by 6. So I could write f of x equals, what's 6 divided by 3? Remember, we're going to divide the y value by the x. So we have the change in my y divided by the change in my x. So that would be 2x equals, or 2x plus what? Well, what's across from 0? Well, it's 0. Well, you could write down a plus 0, but it's not needed. So the real answer is f of x is equal to 2x. Sometimes we're not adding anything. Sometimes we're just multiplying. It really is that simple. Okay, let's look at 2 more examples to see if we understand. Whoosh! Magic! 2 more problems. Here we have in x column, we have a -1, a 0, a 1, and a 2. So it seems to me that there's an increase, again, of simply plus 1, okay? While over here, there seems to be an increase of 2. So we have 2 divided by 1. That would once again get us f of x equals 2, because 2 divided by 1 is 2. X, what's across from the 0? Oh, look, it's another 0. So this is another one, but notice the charts are different. Look at this chart and the other chart, but the equations are the same. So you should notice that you can sometimes get it even though you're using different charts, because sometimes the charts contain different numbers. The other one we had, this was going up, so it was increasing by 4, while the other one we were using 2 over here. We were jumping by 2s instead of 1s. So same equation and really the same values. If you look at the numbers, they'll still match up. Just wanted you to see that. All right, next, what's the increase or decrease over here? It seems to be increasing by 2. But over here, it seems like we're going down, like a decrease, a minus of 4. So that would mean that I have f of x is equal to, what's negative 4 divided by 2? Well, that would be negative 2x. What's across from my 0? Minus 1. You could put plus, minus, or plus negative 1. You could put plus negative 1, or you could just put minus 1. Either way, it's the same thing. So plus a negative or just minus a positive. I prefer this way because it's just less writing. Not much, but just a little. And so that's our final answer there. Now, we've seen a variety of different two-step formulas, so there's a variety of different rules that you can get for this. So be prepared to ask questions in class. See ya. Bye-bye.